Good afternoon, everybody. After this presentation now, I feel I have to explain myself. Pink colors. I just joined this company and they told me, yes, we have this slide deck. And I'm like, I never do slides with these pastel colors. Yeah, this is safe, this is nice, right? So you're gonna see a presentation now that is very light, anthropic kind. So yeah, bear with me with that. I'm Xavier Anguera. I'm from a place called Catalunya near Barcelona. And now I'm working with Babel. Babel is a language learning company. We are trying to compete with Duolingo. So many of Duolingo for sure. Some of you might know Babel. And today here, I'm going to tell you something. I want you to go home and talk to your kids. And I want you to go to talk to your wife. But sometimes in other use cases, you also would enjoy speaking to an AI. So I'm going to tell you about that. We're going to talk to here. I hear a hum. I'm going to tell you how to build your AI companion, a companion that you can talk to and it will talk back to you. It's very easy. And I'm going to give you at the end of it, I'm going to give you a link so you can just either use my code or copy paste my plan into your Cloud code and build it for yourself. Okay, so tonight you can be talking to your personal, local, fully local if you want, AI companion. Okay. So I told you a little bit about myself. I've been doing AI for about 25 years. I first, before Babel, I was doing my own company, Elsa Speak. We were teaching people how to speak better in English. Before that, I was doing a PhD. I was doing research, a bunch of stuff. So I would say I started with AI stuff, SVMs, and support vector machines, whatever, in 99, 98, when I was doing my master's. Why am I talking about this? Voice, and is one of the applications that is very well suited for EdTech. So language learning apps and voice, they go together very well. AI and conversational AI has enabled us to build. All of a sudden, you can find, if you go to the App Store, you will find tons of applications where you can actually talk to it. Okay, 10 years ago when I started my previous company, there was nothing. You could do some speech recognition, but there was really nothing that could teach you, coach you like you do nowadays. So this is a very good killer app. And nowadays with this all conversational AI, all free tools, open source, you can build very amazing tools. So what is conversational AI? Many of you know about the chatbots, right? So a chatbot has been there forever. You can go into some company, you have this little thing on the screen, you can go chat customer support, they can automate that now. Everybody wants to automate, save on human power. Not all of them upskill them like IKEA. I heard IKEA, right? Not all of them upskill them, but unfortunately, but you can talk by chat. This is totally asynchronous, right? When you're gonna go and talk with conversational AI, you have a lot of problems. You have to be very fast at computing. So all the latency problems, if you are too slow, the conversation is not nice. So you want to have a bot or something you can talk to and then get an answer and make it natural. You are bringing in a lot of the prosody pitch. Depending on how you say it, you will want the AI to respond to you, and you will want also the AI to respond in the same sort of tone variation so that the conversation is natural. There is the whole turn-taking thing, which is, okay, when do I finish my thought, right? Am I making a pause because I'm thinking of what else to say and I want the AI to wait patiently, or am I done and I want you to answer right away? And also interruption, what's called barging. I'll talk to you about that in a second. Is the AI is telling me something, I know where it's going already. Many times we can even see it in the transcript, and we want just to interrupt and say the next thing, right? So all this is about conversation, and conversational AI is this thing. So conversational AI technology allows us to build a system that will allow us to have a conversation, to interact with information with an AI in the same way as we would be talking, you and me in here. And this is already here. So I'm not talking about science fiction, right? So many of you might know Character AI, this company. It became very famous because some little kid took his life after talking many hours with one of their characters. I'll talk about that in a second, but those are like, this company grew up enormously, like enormous session lengths, Ribbling, TikTok, and others like that. Duolingo has 500 million users and has this thing called Duolingo Max where you can actually have conversations with this Lily character, very out there girl, and now with a bear. You can actually have conversations at scale. They are proving that this is working. Tons of users online and tons of usage of voice. So users online, users in their homes using all these Alexas and Siris, and maybe not in Europe, but Alexas and Siris and all these little things. Even my mother-in-law, she has the little Google Dot, it's called, at home, and she plays with it. So this exists, right? It's here, right? Now, how can we leverage it? How can we bring it, make it our own? Use cases, companionship, elder people. Like my mom, she loves talking to Alexa. She's like, Alexa, what's the weather today? I'm like, again? But she loves it. She loves having these small conversations and, oh, tell me a joke or this or that, right? And so it's a good start. I love talking to my mom, but not 24 hours a day, right? So there is all these times that this fights mental decay, and that's a very good thing. For EdTech, I told you about it, right? So you can learn from the textbook. You can learn how things are spelled, how vocabulary, grammar, but then you want to put it in practice. The problem I had when I was growing up is I went to the US and I didn't know how to pronounce things, right? I didn't know that this was a hat and not a hood or a hat, no? So things like that. So EdTech is a great use case for conversational AI. Customer service, hopefully not reskilling people, but it's a great way for people that just want to get something solved. We saw it with the Quinto Andar talk this morning. We want to get something solved. We talk there. There's always an Asian assisting us. And if it gets complicated, it goes to a human, right? And other applications, Internet of Things, in-car, there is tons of applications where speaking interface will come in handy. I have big hands as well, right? Typing in my phone is not very comfortable. So being able to speak to it is very nice. So we always have the dark side as well, right? I talked a little bit about these problems of people taking their lives. This is one of the biggest surfacing problems that we have, right? People not understanding they're talking to an AI that doesn't have a soul, that will just tell you whatever came as the biggest, most probable result, right? But there is also hallucinated advice. There is also problems with guardrailing it. So when we talked before, somebody was talking about medical advice, right? You were talking about that. You're talking about everything. So medical advice, right? An AI, unless it's really specifically trained for that, it will just tell you whatever is the most probable there, right? So if people are thinking that when they are talking to an AI, because they are talking, because it seems like so natural, the thing is actually answering to them the right thing, no, think twice, right? And the same way, right? Guardrailing, you need to make sure that it just doesn't go into directions that it can harm you or anything. So I wanted to have this quote here, right? If you're building something that has conversational AI on it, after you see my code, please think that this can actually harm people. And this can actually, you have to really be careful with this. Anyway, until now, introduction. Now, how do we build it? So that's where you get your laptops are. Don't answer email, but start typing, right? You can do it in two ways. Very simple. First, you can get an end-to-end system. So that's something that voice comes in. The same model handles the voice input. This voice gets converted to tokens. Those go into an internal LLM, converted back to voice, back to you. Very fast in and out. So latency is not a problem, but very limited in what you can do with it. It's like normally closed systems that you have to either buy into a vendor or you cannot change it very much, right? So this is not what I like, but there is companies like Moshi. Moshi is an open source. You can try download it, but other things that are more commercial like GPT from OpenAI, Google, NVIDIA has something. Sometimes for production systems, if it works for you, this could scale pretty nicely. You could look into this. I love more the cascaded, the ASR, which is speech recognition, plus intelligence, the LLM, plus text-to-speech, which is the output. So combining them. Now, danger, of course, you have more components to tune and you have latency to handle, right? And I will talk about these things in a second. But these are much more modular. They are auditable. You can swap things, and there is a very rich open source community out there, which is even, I think that this is the curse of these things. We can do everything now. Now the question is, how do we choose? Okay. Even this weekend, I was planning for this talk. and I was trying to put together something, and at the end I'm like, no, I swapped it to something else, and it worked right away, right? So sometimes we need to play with the components a little bit for it to work well. So this is my, nowadays, all these AI generated images that they look so nicely. This is just me building boxes in a drawing thing. So this is my system. So we have a input from a microphone, voice activity detection. I'll tell you about that. Is the system that allows to detect when you're speaking, so you can barge into the AI, and allows to tell you when you stop speaking so that the AI starts to respond to you. Then you convert the speech to text or speech recognition. You go into a dialogue manager, somebody that handles that text input, does the understanding, so it's a natural language understanding, and then does the generation, natural language generation, which normally goes into an intelligent system that we use an LLM for that. And then the generation, the text that you generated, text to speech out. I would say 20 years ago, I was already looking at these dialogue systems. So of course, many of these blocks were not there, not even the voice activity detection. There were like very crappy systems out there. It's so good to see that nowadays we can build this so easily, and you'll see in a couple of minutes, if I do have plenty of time. Some design constraints, right? What do we want to get to? What do we need to care about when we want to build this, right? Response latency. So I won't go into the ITU standards that say 200 milliseconds back and forth. There's a lot of studies on that when people were doing the telephone lines. But you agree with me, if you are in the telephone with somebody and it starts taking too long time until you hear back from them, it sounds very awkward, right? So in here, it's more or less understood that about 500 milliseconds should be the maximum time that, or the time you should aim for a really good communication back and forth, right? So the moment you stop speaking, then about half a second, maximum 1 second, you should get the answer from the system. So that's very fast. You need to compute very fast. That means streaming first, everything streaming. And streaming doesn't mean every single byte. Sometimes it's at the sentence level, but no more than that. You cannot just send like a WhatsApp, right? You send the whole message, wait, send the message back. No, it needs to be going up and down all the time. Barge in to possibility to interrupt, so you can just break it anytime, say something else. Accurate speech recognition. You don't want the system to understand the wrong thing and talk about the weather when you want to ask about the stock market, right? Natural sounding text to speech. This is something that nowadays has also become so nice. There is this whole theory of the uncanny valley, right? So 5 years ago, we would hear artificial text to speech, and we would be like, nowadays, we don't even recognize a real speech from artificial one. I can even show you my laptop. I have my voice cloned, and my kids, they're like, whoa, this is you. I'm like, perfect, right? Where am I? Intelligent but fast LLM. Nowadays, we have very good LLMs, but they are slow. So we need to do here, how do you say it? 6, 7, right? Here. And some system memory. So we do want it to remember something. It's so sad, right? When we talk to somebody and 2 minutes after say, what's your name again? So we need it to be a little, remember what you said before. Latency, I talked about that before. I wanted to double click on that. Excellent system is under 500 milliseconds. You can go acceptable up to 1.2 seconds. Over that, your system will start to lag. You'll feel it. You'll really feel it. And this is not easy. So this is a little bit, I took it from somewhere online and I thought it was very nice representation. All these different steps, they add some time to it, right? So if you have it all local, is the line above. So audio input, just the microphone, the system, the capture, it will take you 50 milliseconds, 30, 50 milliseconds. ASR will take a little bit, 150, 200 milliseconds. The LLM response, another 400, 500. TTS synthesis, 250. If you sum them up, is about 800 milliseconds. If you have to go to the network, adds a little bit more delay. You need to be working here with the numbers. It is possible. It is possible. What else? We have many options to implement this, right? And some of them are vendors. Some of them are we can build ourselves right now. And I'm going to go for the last one, which is the do-it-yourself one. But to mention here, some fans here of Hermes or OpenClaw, you can build it. It's not a platform that has been designed for this, but you can do it. managed transport layer. So there is companies that are actually selling this as a product. There is the retail, VAPI, and that give you the whole transport layers. So you can go into telephony, you can go up and down. So this is another option. You can go to 11 Labs, TTS company that is becoming now very ubiquitous in many different services and others to just purchase an agent from them, and then you will have this thing. You just need to plug it into some end application, or the option we were going to, zero marginal cost. Everything can be local with some caveats, but that's what I'm going to tell you a little bit more about. So hardware requirements. You cannot just build it in an Arduino yet. Some people have tried and managed somehow. So I would recommend something like a mid-level laptop. My Mac here has 32 gigabytes of RAM, plenty of it to run everything local, but less than that, you might have to start choosing things and then have a bit of a GPU or an Apple Silicon thing so that you can run comfortably things. One way that in the code I'll disponibilize, one trade-off I've taken is I've done everything local except for the LLM. LLM locals, they can run with Llama, run with LLM Studio, and they are okay, but they tend to be a little bit slower or very less intelligent than I would like to. I've been using the OpenAI 4.0 mini, I think, which doesn't have reasoning and it's very fast and it's still intelligent enough, but you can replace that very easily. And this is what you're going to see. And that's a screenshot of the agent. I have it running there. If we have time, I can show you actually a conversation with it. So what do we do here? This is, I wanted to put in parentheses all the toolkits that you're going to use to plug it in. When you come in, the voice comes in. Remember the schema before, same thing. The voice comes in. We want to do a little bit of a cleanup, noise cleanup. There is this tool, RN Noise. Will clean your voice up, take out all the noise behind it, so it's very nice and tidy for your speech recognizer. Silero voice activity detection, the industry standard, fantastic, works very well for knowing when you are interrupting, knowing when you're finishing to talk. Who doesn't know Whisper here, right? Whisper, ASR, there is better things, but this works very nice and very fast. Pipecut, I'll tell you about it. This is my orchestrator, puts everything together, works everything. I told you about OpenAI, GPT-4o mini. You can use whatever you want. I was trying my first experiments with 5.0 mini, 5.4 mini, but I was seeing, oh, it's very intelligent, but it's very slow. So then I switched to this, boom, no thinking, goes right away. Maybe a little bit more stupid. Some memory, I discovered this thing called Hindsight, very nice. I like it, very easy to work with. TTS, you can use whatever external. Kokoro is an internal option that has everything I need for the next step, which is the part that everybody loves, which is a talking head. So actually see an avatar that opens and lip syncs with you. This is nice. Let's go to a few of these. Pipecut, orchestration, go online. This is amazing. Open source. All of it is open source, okay? And I don't like to putting these things on the slide because nobody reads it, but you can see these are all the plugins, all the ins and outs that it accepts. You can almost plug everything you want to it, right? And many of those things you saw in the schema before, they just plugged into here, okay? What else? Voice activity detection. So for those of you that are like, oh, wait, what is this? So a little schema here, my AI is talking, and then at some point I'm like, oh, wait, so he wanted to talk this whole thing, but I just interrupted. There is a little bit of time that the Silero will take to get it, but right away, boom, then I'm speaking. Once I finish speaking, a little bit of time that the voice activity detection will trigger, and we'll say normally it's like very little, 0.2 seconds, whatever. And then it starts processing ASR, LLM, TTS, and then the bot answers again, right? So here we see we have an interruption about a barge in, and we have an end of sentence detection. And that's where Silero voice activity detection works wonders. What else? Text to speech to text, ASR. This has to work very well. And I wanted to show you here a little bit of the history in the recent years. 2017 is when we started seeing, oh, hold on, this thing actually can work very well. Before that, word error rates were in the 20s, 30s%, the best, right? And 20, 30% means that 30% of the words are not correctly identified. Therefore, whatever you say, it will take something else. Now, as we go down and down over the years, and like last year, we got almost to 1%, which is almost human parity. Like only 1% of the words don't get identified. That means you can say whatever you want in whatever noisy conditions you want, boom, it will get it, okay? In the code you'll get, I went for a single model LLM. This is your thinking power, right? So that means, okay, I have a message. Hey, LLM, this is my message. This is my context. This is my history. Give me an answer. That's fast. That's cheap. That's where we use the OpenAI 4.0 mini. We get an answer right away. Now, if you're like, oh, you're too dumb, then you need to go to a dual model, which means that you have a fast model that generates the responses, conversationally talks to you, while a more complex model in the background manages the invoices, right? Manages the end-to-end, manages your memory, manages how things get answered. This is two possibilities here. And there is many ways here that you can do this dual model. You can hook things in different ways. There's tons of literature you can go and look. What else? I'm talking about memory. So different types of memory, right? Maybe you know this in-context working memory where all the context from your current conversation gets appended to every call so that it knows what you just said. But then you start a new conversation and it's like, okay, so what's your name again? So that's where you want to see, you want to have the past sessions in the episodic memory. But then you also might want to have semantic memory. So it remembers things about me. It remembers things of who I am, what I told it. Or you even want to have some procedural memory, and that's where the OpenClaw does it very well, right? It's the soul or whatever it's called, which knows what it is, which knows things about himself as well, so that it can respond accordingly. As I said, there is tons of different possibilities. Hindsight works very well for me, but there is Mem0, there is other local versions that they have an open source we can use. And giving it a voice. You can go to 11 Labs, amazing service, very nice. A competitor of it, Cartesia, they say they have much better quality. At some point, you stop feeling it, right? But you test by yourself. If you want to go local, Kokoro, the one we use, very small, very fast. You don't have many options unless you fine-tune the voices. You have other very small ones like Piper, and a very nice that I love, OmniVoice. This is the one where I tricked my kids. I cloned my voice with it. OmniVoice to me is one of the top, but it's limited in functionality. So I'm using Kokoro here instead. What else? Oh, and face. Okay, we want to give it a face, right? So we want to have an avatar talking, right? So Talking Head, I love it. I used it here. You can also go with Rife. Rife is this technology that is used by the Duolingo guys, and it's mobile ready. Talking Head is more for a web system. If you want to go and buy something, you can go with HeyGen or Simply, where you have these total human-looking avatars. The other ones, you will notice you're talking to an AI. In here, you might not even notice it. That's when North Koreans come into your interviews, and you're like, because you have to pay per second in there. And then just a comment here about lip syncing. You really want the avatar to, in some way, see that he's talking to you. So yeah, I told you about all these different boxes. I'm out of time. So this is the avatar I built. Okay, so you saw her speaking up. This is what I said. And I was playing with it. You take the repo here and picture, please. Duplicate it. So clone it or take the plan. You can do it at home, and you will get something similar to this. I'll leave you this afterwards. Just going to the extensions. So I tried to have an avatar that was a little bit more personal. Does it look like me? Weirdly, yes, right? So yeah, I used this avatar open also service, open source. It has a freemium model. I took 3 pictures. It got this image. I have it there talking to me. And yeah, it's very nice. You can also size it and scale it. So you go to system services like Daily or LiveKit that will get it out with WebSocket or WebRTC connection, so you can actually deploy it. You can use telephony hooks like Twilio to make it into telephony-based things. I talked about OmniVoice CTS and Avatar to create avatars from whoever you want. And that's it. Thank you.